In this video, we are going to see two built-in functions available in C language using which we can dynamically allocate memory in our program. So those two built-in functions are malloc and calloc. So to begin with, let us see malloc built-in function using which we can dynamically allocate memory in our program. So malloc, as I said, is a built-in function, and the work of this function, that means the definition part of this built-in function, is already defined by the C programming community or the developers in the stdlib.h header file. Just like we have to include our stdio.h by writing #include stdio.h to have the functionality of scanf and printf, that is standard input output. Similarly, to include or use the functionality of malloc, calloc, realloc and free function, we have to include the header file by writing #include stdlib.h, means standard library.h. Malloc is the short name or the short form for memory allocation. So as the name suggests, it does the allocation of memory, and that too dynamically, and it allocates a single large block of continuous or contiguous memory of the specified size. So the syntax, as we have already seen in the previous introductory video, is you have to call the function by specifying its name and the size of the bytes or the memory that you want to allocate. Okay, and the typecasting must be done. So if you don't do typecasting, it will return a void pointer. Void pointer means the pointer or the memory can accommodate the values of any data type. But we want to store specific data type of value in the reserved memory, right? So we have to do the typecasting. So malloc function simply will allocate the block of memory according to the size that we specify, which is the parameter for this malloc function. And this size of memory which is reserved is in the heap. On success means if the memory has been reserved successfully or has been allocated successfully, then the malloc function returns a pointer, and it will be a void pointer. It will return the pointer to the first byte of the allocated memory. Means if a block of memory is allocated, then the first byte or the first location or the starting address of that memory block, there it returns a pointer, and the address of that starting position will be returned, and it can be stored in the pointer variable, right, as we have seen in the previous video. But suppose due to some case, if the heap area is full, or if memory allocation was not possible, or if there is limited space and the size that you want to reserve is exceeding the available space, then in such cases the malloc function will return the null value, means memory reservation or allocation was unsuccessful. Now what is this size underscore t? This size underscore t stands for the unsigned int. Okay, and this is also a, you can consider it like when we write #define n5. So wherever we use the n, capital N, it will get replaced with its value 5. So similarly, you can consider size underscore t. Okay, it stands for unsigned integer. Okay, means size underscore t is like here the data type of this size. The data type of size is size underscore t, and size underscore t means unsigned int, which is defined in the stdlib.h. So this size variable can hold only a positive integer value. Unsigned integer means positive integer. Unsigned means no sign. Now we have only positive or negative sign. Positive, if we write +5, it is nothing but 5 itself. But if we write -5, it means -5. So minus is considered as the sign. If it is not a sign, means unsigned. Unsigned means positive value. So size variable can store only positive integer value. Okay, if you don't want to write size underscore t, if you don't want to understand this, then you simply understand that you must write it is nothing but int size, where int size is a size variable can hold only the positive integer values. Okay, simply consider that positive integer value should be passed as a parameter to this malloc function. Let us see one example here. In this example, malloc is being used. So as I said, we have already seen in the previous video, int asterisk pointer variable name is equal to, we have typecasted it to integer, and malloc size of int. And if we want the space of 5 integers, means it is nothing but 5 into size of int means 5 into 4, because size of int is what, 4. Okay, and since size of int is 4, 5 into 4, so what will happen is ptr is equal to this block. And what is the size of this block? It is 5 into 4. 5 into 4 means 20, and it is bytes. Okay, memory is allocated in bytes using malloc, calloc, realloc, and all. So a large 20 byte block is allocated dynamically, which can be accessed using this pointer ptr, and you can store values in this block using ptr. So consider heap area as a random space of memory. Okay, it is not necessary that it is structured or anything. Another difference between your static memory and your heap area is your static memory, that is you use stack memory section over there, and there allocating and deallocating memory is by a specific rule done by the compiler. When the function is called memory allocated, when the function you are returning from the function, that time memory deallocated. But in heap, the programmer, that is you, will decide when to allocate and when to deallocate. So it is totally dependent upon you. Maybe at the end of the program you will deallocate, or maybe somewhere in the middle of the program code. So that it is not a specified set of rules that now you have to deallocate, now you have to allocate, and so on. It is totally dependent upon you, that is the programmer. So this is a block of memory will be allocated in the heap area. Okay, now why void pointer? I have already told you why void pointer. Malloc does not have an idea of what type of data you want to store in that memory which you have reserved. So it just allocates the memory that the user will request, that the programmer requests, without knowing the type of data that you want to store. So void pointer has to be typecasted to the appropriate type depending on the value that you want to store in that reserved memory area. So instead of size of int, you can also pass a integer value 4 like this. Okay, it's absolutely fine. But standard way is specifying size of data type and typecast it. Malloc will allocate 4 bytes of memory in this example, and the address of the first location in that reserved area which you have reserved, the address of that first location, that will be returned, and it will become the value of this ptr. It will be accessed by ptr. So let us see this program. Include the header file stdio.h for printf scanf utility. Include this stdlib.h to have the malloc, calloc, realloc, and free utility. Then call this, define this main function. You have two variables, integer I and n. So first step is tell the programmer enter the number of integers, means how many integers you want to include in your program, you want to enter in your program. So that number of integers will be stored in the n variable. And then, so this is the case of dynamic memory allocation. So what you will do, int asterisk ptr is equal to malloc n into size of int, means the programmer wants to use n integers in his program, right? So each integer is of 4 bytes, means each integer is of size of int. And since you want to have n integers, so n into size of int. N can be 5 for anything. So if you want to have 5 integers, then n will become 5, and 5 into size of int is 4. So it will become 20. Suppose n is 6, then 6 into 4. So you will have the 24 bytes of memory reserved. Okay. So that is what is being done here. Then, as I mentioned, if the size is limited or if it is not available, then this whatever is returned by malloc will be null. So null will become the initialization of ptr. So if ptr is null, that means memory is not available or unsuccessful memory reservation. If that is the case, if it is unsuccessful, then what should happen? You should print out some message just for your knowledge or understanding that memory is not available and exit from your program. Okay, but suppose ptr is not null, means memory allocation and reservation is successful. That time if condition will not get executed, directly you will not exit from the program. What you will do, you will run a for loop in order to accept the integers from the user. You have asked the user that you want how many integers? User has entered 5 integers. So now you have to accept those 5 integers from the user. For that, we'll run this for loop. 5 integers, so 0 to less than n means 5 times the loop will run. You know this. Enter an integer. So at the scanf means at the address we will store the integer, right? We have seen this already in the previous program in which I discussed about pointer to array concept. Okay, you see that video, you'll understand it better. And then we want to display the integers that we have accepted from the user. So same for loop, but this time asterisk you have to write. So asterisk of the address means value at the address, and you will be able to print the values one by one. So I hope you have understood this program. Now let us run this program. When I run the program, first statement is enter the number of integers. So that has been displayed. Then suppose I enter the number of integers is 3. That means I want to store 3 integers in my program. So I have entered the integers as 43, 56, and 78. And then click on enter. So I am getting the output that which integers I had entered using this malloc, that is dynamic memory allocation, and pointers concept. Next, we will study calloc. Calloc means it is similar to malloc, but there is certain features, additional features that you can get using calloc. Now, calloc function is used to dynamically allocate multiple blocks of memory. Okay. Now, how this is possible? It is different from malloc in two ways. First difference is that the syntax, obviously. So calloc will need the 2 arguments that you need to pass to its function calling instead of 1. In malloc, we simply pass the size. Okay. But here 2 parameters, that is size. That means how many elements. Suppose you have an array, you want to store 5 elements in the heap memory. So and each element is an integer. So you want to store 5 integers. So here the n value is nothing but how many integers. For example, 5. And size of each integer also you need to specify as the second parameter. Suppose integers occupying 4 bytes. Okay. So this is similar to malloc, but there's a slight difference. In malloc, what we did, suppose we wanted to have 5 integers. Then what we did, like this. Suppose we wanted 5 integers. Then we did 5 into size of int. But in calloc, what is the change? Typecasting will remain the same. Then you must write calloc. And then instead of writing 5 into size of int, you must write 5 comma size of int. Okay. So it will do the same thing. How malloc will understand the what the user wants to do, you must specify 5 into the size. But in case of calloc, 5 comma size. Okay. Next difference. For example, suppose we have this particular code, calloc 10 comma size of int. Means here what we want to do, we want to allocate a space for storing 10 integer values. If we wanted to do it by malloc, what we would do, 10 into size of int. Okay, so how calloc will work? Another example, if we want to store 5 integers, then 5 comma size of int. So in this case, what will happen? You can consider that there are divisions in your block of memory to store 5 integer values. Okay, as you can see here. And each section or each block will be of 4 bytes because integer occupies 4 bytes. So 5 times you can store 4 bytes, or 5 times you can store 4 integers. Sorry, 5 times you can store 4 bytes, or 5 times you can store an integer. Okay. 5 blocks of memory, each of 4 bytes. Each block is of 4 bytes. That 5 blocks you will be able to allocate or reserve. But in malloc, what happened? It was a continuous block, okay? And you were referring it to by PTR of 0 or PTR of 1 and so on, okay? Another difference is memory allocated by calloc will always be initialized to 0. For example, if you did it using malloc, okay, you have done malloc 5 into size of int. Then what would happen if you want to access the elements? Suppose you do that. Just a minute. If you want to store 3 integers, then you'll do it this way. Okay. And in this case, if you want to access the elements, if you want to access or store the elements in the memory, then what you would have to do to access them, if you want to print out the value in the memory, then asterisk p1, or you'll say, if p1 is the pointer, then asterisk p1 or asterisk p1 plus 0, or you can do it as p1 of 0. Any of one of these you can use, and you'll display the value at the first location in that memory. If you want to access the element at the second location of that memory, then p1 of 1 or asterisk p1 plus 1. If you want to access the third element, then asterisk p1 plus 2 or p1 of 2. Okay. And now when you print out these values, see, we have not stored anything, right, in the memory. We are directly printing out. So there should be garbage value, right? There will be garbage value. Or previously, if that location was used and it had not been freed, then the previous value that will be printed out. Okay. We are not storing anything. We are directly printing out that what is the value at that location. Okay. We are directly printing out what is the value at that location. So it will be garbage. So if I run this program, as you can see here, any garbage value, sometimes such a big number, sometimes 0, and so on. Okay. So in malloc, if you directly access the memory, whatever garbage or previous value was there, that will get printed out. But in calloc, that does not happen. If you did the same thing, but instead of malloc, you used calloc, then by default, the values in the memory will be initialized to 0. Okay. It is opposite or different from malloc. Malloc will initialize the memory, or it will leave the memory to garbage value by default. But by default, calloc will initialize or set the values to 0. So malloc and calloc has this difference also. Okay, let us see how it differences. So this time I'm using calloc. Okay. And I'm using the pointer p2. So I'll just make the changes here. So if I want to use the same thing, store 3 integers or reserve memory for 3 integers, I'll use this particular syntax for calloc. And then I'm printing the integer or the value at the first location, second location, and third location. So this time the output should be 0, as you can see here. Right? Means all the values in the memory are by default initialized to 0. And later on I can change it if I want, but by default it will be 0 and not garbage. So this is another difference between malloc and calloc. And note that malloc and calloc both will return the null pointer if it is unsuccessful memory storage or allocation, or if memory is limited or not available in the heap. So for both you have to do typecasting. And calloc stands for clear allocation or continuous allocation. And malloc stands for memory allocation. So I hope this video was helpful to you and you have understood 2 ways to allocate memory in your program dynamically using malloc and calloc, and what are the differences between them. You can run different programs. You can execute this particular program that we saw for malloc. You can execute the same program for calloc as well. Okay. So thank you for watching this video. If you have any doubts, you can contact me anytime.